maths or mathematical literacy, the properties and the concepts that you learn with quadrilaterals, both as shapes and also within measurement, is going to carry you all the way up. And when you get to like grade 11 matric, we just expect you to know the stuff. We don't revise it with you. We just expect you to know it. So getting the stuff right now is really, really important. Okay, so my first question to you, and you can put it on the chat for me, is what is a quadrilateral? So when I say the word quadrilateral, what do I mean? So what is a quadrilateral? And you can put it in the chat for me. If anyone's feeling brave and wants to raise their hand to tell us a definition of a quadrilateral, that would be nice as well. So if you're feeling brave and you want to give a definition and you want to raise your hand. Hi, Sean. Sean, what is a quadrilateral?
My quadrilateral is quadrilaterals are shapes that equals to 360 degrees.
Okay, cool. So one definition that we can use for quadrilaterals is in terms of their angles. And so all their interior angles add up to 360 degrees. Perfect. Anything else you want to add?
Ma'am.
Cool. All right. So we can define quadrilaterals based on their angles. If we look at the actual word quad, and it can relate to both angles and sides, I suppose. I don't know why everything's just not working at the moment. Right, we got it. So if we look at the word quadrilateral, so this prefix quad means 4. Okay, so automatically we should be thinking 4. And so if we go from Sean's definition, we have got 4 interior angles that add up to 360 degrees. So unlike a triangle where our sum is 180, a quad is 360. And we can go a step further, which a lot of you have said in the chat. We can now refer to the number of sides. So a quadrilateral is a closed 2D shape. And when I say closed, it means that all the vertices end up joining. There's no weird gap. So it's not like something like that where we've got this open space. It's closed. So it's a closed 2D shape with 4 sides. Right, so quad, we've got those 4 interior angles adding up to 360. Or we can go the other way and refer to our sides. It's a shape with 4 sides. Okay, specifically a closed shape. Excuse me, it's very rare we're ever going to start talking about open shapes. Sometimes we talk about irregular shapes, and a quad could potentially be irregular. But at the end of the day, what we need to know is that it's got 4 sides and the interior angles add up to 360. That's just a basic quadrilateral. All right, we can now start to look at specific types of quadrilaterals, and we have to know their properties. Okay, so guys, the first bit of this lesson, we'll see how far we get, but for the first sort of half of this lesson, it's going to be a lot of just, I don't want to say me talking, but it's going to be a lot of just revising, hopefully, characteristics that we know of quadrilaterals. So I am going to ask a few times for you to put answers in the chat if you're feeling brave to raise your hand. So let's just listen carefully and all be on the same page and all focused. All right, so what we're going to have a look at now are our specific types of quadrilaterals that we need to work with. Now, guys, like I say, you're going to work with these in geometry, and they also come up in your measurement section. So when we start doing measurement, like perimeter and area and stuff, we're going to look at these quadrilaterals again. So once we've finished with this family tree that we're going to look at, I'm going to tell you, you can take a screenshot, and I would keep that because it's going to be important for you for the rest of your high school career. All right, so the first sort of quad that we're going to have a look at are our trapezoids, or we can call them trapeziums. It means exactly the same thing. Trapezoid, trapezium, same shape. Really just depends what you prefer. Alrighty, so can anyone, just take that off, can anyone on the chat give me a characteristic of a trapezium or of a trapezoid? So what is a unique characteristic that makes a trapezium a trapezium? Can anyone tell me what a trapezium is? Okay, good. Right, so there's a couple coming in and all of them are looking good. But the defining characteristic that we need to know for a trapezium is the fact that we have one pair of parallel sides equal. Now guys, when I say one pair, that's opposed to two pairs. So if we say, for example, had a parallelogram, which we'll talk about just now, there are two pairs of parallel sides. Now remember guys, we use the arrows on a line to show that they are parallel. So we've got one pair of parallel sides. And that's really our defining characteristic of a trapezium. So there's not too much we need to know. Yes, we can definitely go and say sides aren't equal, angles aren't equal. That's all absolutely fine. But the really important characteristic we need to know is that there's one pair of parallel sides. Now we do get a special type of trapezium, which is called an isosceles trapezium. Make sure I spot that correctly. Whereby not only do you have this pair of parallel sides, but then the sides that are not parallel to each other are equal. So for an isosceles trapezium, we have our one pair of parallel sides. And the pair of sides, or the sides that aren't parallel, are equal to each other. Stop. Right, so we do get that special type of trapezium, which is an isosceles trapezium. And so that is an extra characteristic where the sides that are not parallel are in actual fact equal to each other. So those are your trapezoids, trapeziums. Like I say, they're not, I don't want to say they're not special because that sounds mean, but they don't have a lot of characteristics that we need to know. We need to know that there's this pair of parallel sides, and that's really it. Alrighty. So I'm going to stop here, take your screenshot of the trapeziums, and then we're going to have a look at our next quadrilateral, which is the kite. Okay, so if you've got your screenshots, you can start thinking about some characteristics of the kite that you know about. And I don't put them on the chat just yet. I'll ask you in a second, but just start thinking about them. Alrighty. So guys, our next quad that we need to know are kites. So kites we use a little bit more. They're a little bit more specialized. So on the chat, is anyone able to give me any characteristics of our kite? Right, you should be able to see the screen now. Nice, guys. I like the way some of us are describing these characteristics as well. Very, very nice. Okay, cool. So I'm going to take a lot of what you guys have said here. I like that someone's mentioned diagonals. Well done. And we're going to put it onto our diagram. Okay, so the first thing about our kite, and someone right at the beginning said it, I can't remember, but a lot of you were sort of putting this down, is the fact that our adjacent sides are equal. Now remember guys, adjacent means next to. actually, let's rephrase that a bit better. So 2 pairs of adjacent sides are equal. And again, adjacent means next to. Now, guys, when we have equal sides, like we saw with the isosceles trapezium, we use a line. So these two sides would be equal here at the top, and those ones going down would be equal. They're next to each other, so they're adjacent sides. They are equal to each other. All right, the next characteristic that I saw pop up that you guys mentioned was the fact that we have one pair of opposite angles equal. And someone on the chat actually described it really nicely. A few of you have said it, but Hayden said where the two unequal sides meet, that's where we've got our equal angles. So here is an angle equal to the angle opposite it. In terms of the other two angles, they are not equal, but once we start talking about the diagonal actually cuts the other angles in half, but we'll get there in a second. Okay, guys, importantly, a kite does not have any parallel sides, so there are no parallel sides here. But a lot of you are now starting to talk about the diagonal, which is awesome. And our diagonal, I wonder if I can do this. I don't think I can. Our diagonals intersect or cut each other at 90 degrees. So the diagonals intersect, or we can say cut each other at 90 degrees. All right, so a few of you put that characteristic on the chat. One of you also said that one diagonal bisects the other, so only one is cut in half. So we'll put that there as well. One diagonal is bisected. Now, guys, bi means two, sect generally means cut. So one diagonal is bisected means one is cut in half. Right, generally it is the shorter of the two diagonals, but we can see here that one of our diagonals is cut in half. Okay, and like I said earlier, we also have a characteristic with our angles, whereby one pair of angles is bisected by a diagonal. Maybe let's actually reword that a bit differently. So let's say the unequal opposite angles, because remember, we've already got a pair of angles that are equal in the pink. So now the unequal opposite angles are bisected by the diagonal. And again, bisected means cut in half. Right, so this angle gets cut in half and is equal to that angle. This angle at the top gets cut in half and is equal to that angle. All right, so quite a few more characteristics for a kite versus a trapezium. We can see that. But again, all really important bits of information that we need to know. Now, guys, one thing that's really important to notice is that because, like a lot of you have said, our diagonals cut each other at 90 degrees, what we actually end up creating is 4 right-angled triangles in a kite. And so what I just want you to bear in mind is that if you are maybe trying to find the length of one of the sides of your kite, if you have enough information, you could end up using Pythagoras. All right, so these are all things that we need to now start linking together so that we can start using our quadrilaterals. But our characteristics of our kite, 2 pairs of adjacent sides equal, excuse me, so sorry. 2 pairs of adjacent sides equal, one pair of opposite sides equal. Our diagonals intersect at 90. One diagonal gets cut in half or is bisected. And the angles that are not equal to each other, they then are cut in half by one of our diagonals. So those are our characteristics of a kite. And like I say, because of the way the diagonals sit, we end up with a bunch of right angle triangles that we can potentially use Pythagoras in. So just something to bear in mind. Always useful to know what rules and what theorems we can use where. So I'm going to wait a second, take your screenshot of the kite properties, and then we're going to start getting into the really interesting ones and the ones we use a lot more. Right, and grade 8s, please remember that as we're doing this, because I'm very much just giving you information, if you have questions, please just put them on the chat and I will deal with them. I'm not really going to stop for questions just because I'm not doing examples or anything like that just yet. So if you have a question, please put it on the chat. Alrighty, so let's have a look at our next one. Our next quad that we're going to have a look at is a parallelogram. So we're going to do it a bit differently. If anyone wants to raise their hand to give me a characteristic of our parallelogram, you may do so. Watobe?
One characteristic is that both pairs of opposite sides are equal.
Can you just say the first bit again for me?
Both pairs of opposite sides are equal.
Perfect. Sorry, you broke up a little bit there. Okay, perfect, guys. So this is the first really important characteristic that we have of our parallelogram. Both pairs of opposite sides are equal. Now remember, we use a line on our diagram to illustrate that. So, whoopsie, let's try to do that a bit better. Those opposite sides are equal to each other. Those opposite sides are equal to each other. So the length of them equal. Oh, sorry, my nose. Okay, Kutlano?
The opposite angles of a parallelogram are equal.
Perfect. Opposite angles are equal. Equal. So this angle would be equal to this angle equal to this angle. And guys, remember, these are all quadrilaterals. So for any quad, we can automatically assume that they will add up to 360 degrees. We don't have to put that for every single quad. As long as it's a quad, you can say that. Kutlano? No, sorry, that's not how you say your name. I apologize.
It has two diagonals that bisect each other.
Nice. Okay. So we've got two diagonals that bisect each other. Now, guys, that's really important. They each cut each other in half. So it's not just one diagonal that gets bisected like a kite. Both of them get cut in half. Okay, so when we draw our diagonals, I always draw a diagonal with a dotted line, just because it's not actually a side that makes up my quad, but it is an important line in my quad. These diagonals cut each other in half. Okay, so they get cut in half. That was a weird situation that I did there. And that is one of our characteristics. Sunyane, another one?
Both pairs of opposite sides are equal.
Okay, cool. So we've got that in our first pink.
Both pairs of opposite sides are parallel.
Yeah, there we go. Nice. Right, so guys, it's a parallelogram. I thought that was actually going to be the first one. Both pairs of opposite sides are parallel. Okay, and that's where the word parallelogram comes from. panic. Let's maybe try spell parallel right. Parallel. That looks weird. Parallel. Sorry, I had a moment of English problems. Okay, so both pairs of our opposite sides are parallel to each other. And again, that's where the name comes from. It's a parallelogram. Watobe, do you have another one?
Consecutive angles in a parallelogram are supplementary.
Yes, sorry, I had to take a second to just work through all of that. Absolutely, and that's a really cool reason. So guys, basically, when you're saying consecutive angles, if we took angle A plus angle B, we'll get 180. If we said angle B plus angle C, we'll get 180. If we said angle C plus angle D, we'll get 180. And that's all because of the parallel lines creating co-interior angles. And so if you think back to your parallel line reasons, that's where that comes from. Nice. Tatenda?
Ma'am, I wanted to say that if you look at the parallelogram, ma'am, it looks like a kite that is rotated.
Yeah, I suppose it does a little bit. So it looks like it's a little bit squished. And when we get to the last couple quads, we'll chat about like how they are a certain thing just squished. Guys, what I just want you to bear in mind is please remember, just because something looks like something doesn't mean it is. But I completely hear what you're saying, Tatenda. Very nice. Kokoslano? There we go.
Each diagonal divides the parallelogram into two congruent and triangles.
Nice. Okay, so if we now start talking about congruency with shapes, excuse me, we definitely do start creating congruent triangles when we start drawing our diagonals. And guys, remember, congruent triangles are triangles that are identical to each other. All right, but those four sort of characteristics that we have here are the four really important ones that we need to know for parallelograms. So let's take a screenshot of that, and then we're going to move on to our next quad. Onshia, I see your question. I don't really know what you mean, calculate a parallelogram. What are you calculating? Are you what calculation are you trying to do? These are just characteristics of a parallelogram. So these are the things that make a parallelogram a parallelogram. So if you're talking about, say, for example, the area of a parallelogram, there's a completely separate formula for that. And we do that when we get to measurement. Okay, so guys, a couple of you are asking me, do they ever ask you to calculate? Is this how you calculate? What are you calculating? Like, calculate doesn't mean anything unless you say specifically what you're calculating. So this is not like, these are just features of a parallelogram. We can use these to then do calculations later. For example, you can work out the length of one of your sides of a parallelogram if you have certain information. You can work out the area of your parallelogram if you have certain information. But we can't just calculate. This is just features. So yes, sometimes we do give you values on these diagrams, and then we ask you to do certain things. And then you're either using these characteristics or measurement formulas that we learn. But right now we're just focusing on the characteristics. But yes, I could put numbers on the diagram and ask you to determine certain things, but we're not there yet. We're just looking at the features right now. Okay, so let's have a look at our next one. So our next quad is a rectangle. So on the chat, what are our characteristics of our rectangle? Let's do it on the chat this time, please. So we're not going to do raise hands for this one. We can do raise hands for another. So can we lower our hands, please, and put our characteristics on the chat for me? We'll do raise hands again later. Nice. Right, I'm just going to start writing them down while they come through, just because otherwise we're going to have a huge backlog. So first sort of characteristic that came through, a closed shape with 4 sides and 4 corners. Yes, and that would be any quadrilateral. What I like there is that we've got 4 right angles. So all 4 angles are 90 degrees. And guys, remember on a diagram, if we want to represent a 90-degree angle, we'll draw a little square at that angle. So all of them are 90 degrees, which means that again, that supplementary characteristic does come in. Right, another one, or another characteristic rather that's come in is that all 4 sides, let's try this again, opposite sides are equal. Sorry. So those opposite sides are equal to each other. Those opposite sides are equal to each other. Another one that came in is the fact that we've got both pairs of parallel sides, both pairs of opposite sides are equal, are parallel. Can't write and talk at the same time. Okay, so opposite sides are parallel. Let's see what else we have coming in here. Our opposite angles are equal, absolutely, because they're all equal to 90. Again, as Botale said there, our diagonals bisect each other. Let's get a different color here. The diagonals bisect each other. And another really important feature of the diagonals is that they are equal in length. So I'm actually going to write this a little bit differently. The diagonals are equal in length and they bisect each other. And this goes back to the comment earlier about the fact that these diagonals are dividing the shape up into congruent triangles, which means that those diagonals have to be equal to each other. And so all of the bisected parts of your diagonals are then equal to each other. All right, you want to make sure, okay, cool, diagonals are equal in length. Interior angles are 90, nice, nice, nice. Opposite sides are equal. Nice, guys. Again, because it's a quadrilateral and because it's a closed regular quadrilateral, we can assume that the interior angles are 360. That'll be true for any regular quadrilateral. I just want to make sure I haven't missed anything from you guys. Nice, I like that we're talking about diagonals. Very nice, guys. So a rectangle is a little different to a parallelogram because now we have those interior angles at 90 degrees. All of them are 90 degrees and our diagonals are equal to each other. Right, very nice. So let's take a screenshot of our rectangle and then we're going to have a look at our next one, which is a rhombus. So you can start thinking about some characteristics of a rhombus that you know about. Okay. So guys, I've got here a rhombus, just it's a silly thing. The plural of a rhombus, so many rhombuses, is actually called many rhombi. So rhombus, rhombi, doesn't really matter, but we're going to call it a rhombus for now. So let's see. Nokutenda's put there, all sides are equal. Absolutely. I feel like my handwriting has deteriorated. Okay, so all 4 of these sides are equal. That is one of the defining characteristics of a rhombus. We also, oh, I just want to make sure I'm not missing anything, sorry. I feel like I have lost my mind a wee bit. There we go. Okay. Opposite sides are equal. Oh, we've done that. Sorry. My mind. Opposite sides are parallel. So again, it makes it a special type of parallelogram because we have these opposite sides parallel. What else do we have? Adjacent sides are equal. That's also a really nice way to say all four sides are equal. Opposite angles are equal to each other. Very nice. Okay, so this angle is equal to this angle, and this angle equal to that angle. Yeah, okay, we'll take it. The diagonals bisect each other, and I'm going on to then the table's comment. They are bisecting each other at 90 degrees, so they are perpendicular to each other. So if we fill that in for ourselves, so the diagonals bisect, cut it in half, each other at 90 degrees. Okay, so when we draw in our diagonals here, okay, that wasn't great. Let me try that again. Good. These diagonals cut each other at 90 degrees, and that's a really, really important characteristic of our rhombus. Okay, good. Opposite angles equal, diagonals bisect. Good, good, good. We've got our parallel lines. Nice. Just making sure we've got everything. Another characteristic, guys, is that the diagonals bisect opposite angles. Bisect opposite angles. So that means because this angle is already equal to this angle, those halves will all be equal. And the same thing for your other. So the diagonals cut the angles in half. I just want to make sure I haven't missed anything. Good, the diagonals are not equal to each other. And again, guys, any regular quadrilateral will have all of its angles adding up to 360 degrees. Right, very nice. I'm impressed with our rhombi knowledge. Well done. Right, so let's take a screenshot of the rhombi characteristics. And then we're going to have a look at the final one, which is like the most specialized type of quad that we work with, which is our square. So you can start thinking about some characteristics. I'm also going to ask you to raise your hand for this one. So don't raise your hand yet, just wait, but start thinking about your characteristics. Okay, right, so we've got our square. Anyone who wants to raise their hand to give me some square characteristics? Lixa?
All sides are equal.
Lixa, I can't hear you. Try again.
Okay, ma'am. All the sides are equal and all angles are equal.
And what do all the angles equal to?
90 degrees.
Awesome. Okay, so guys, first characteristic, all four sides are equal. So similar to a rhombus, So that is the same characteristic as a rhombus, but what's different to a rhombus, but similar to a rectangle, is that all 4 interior angles are 90 degrees. Okay, so a square is sort of combining a rectangle and a rhombus together, forming this one unique shape. Alrighty, I am trying to give everyone a chance. Awande?
Hi, ma'am.
Hi.
All 4 interior angles are equal to 90 degrees.
Okay, perfect. So I've got that there in orange. Very nice. Have you got any other characteristic?
The 2 diagonals of the square are equal to each other.
Good. Okay, cool. So we're going into our diagonals here. The diagonals are equal and they bisect each other. Sorry. So if we draw in our diagonals, boom, 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 boom. They are equal in length to each other and they cut each other in half. So all of these little parts of the diagonals are equal in length. Sorry, guys, I'm causing chaos on my side. Just want to see. Zingubeni?
Hi, ma'am.
Hi.
The diagonals of a square bisect each other at 90 degrees.
Nice. So I'm just going to add it on here. So guys, very similar to a rhombus. Is everyone still there?
Yes, we can still hear.
Okay, sorry, it like my whole Zoom just like closed itself and I thought I'd lost everyone. Okay.
Oh, no. Yeah. Oh.
Okay, cool. So yes, exactly. Our diagonals bisect each other at 90 degrees. So that's a characteristic we're bringing over from the rhombus. Sabiso? Sabiso?
Hello. Hello,
Hi.
ma'am. Opposite sides are both parallel.
Nice. Okay, so guys, bringing in that like parallel rectangle rhombus idea, both pairs of opposite sides are parallel. I nearly forgot about that one. Okay, I'm going to start all of my words again. Both pairs of opposite sides parallel. And again, that makes a square a special type of parallelogram. All right, very nice. Kenya?
Kenya. Ma'am?
Yes.
The interior angles add up to 360.
Sorry, say that again.
The interior angles add up to 360.
Perfect. Okay, so again, guys, any quad, those interior angles are going to add up to 360. Very, very nice. Sibungu?
Hi, ma'am, can you hear me?
Yes.
Diagonals bisect the corner angles.
Nice. Okay, so the last one that we have here is the fact that our diagonals bisect. Golly. Okay, we'll try the words again. Bisect all interior angles. Now, guys, if we know that the interior angles are 90, that means that it cuts these angles, every single one of them, into 45 degrees. Okay, so these diagonals cut my interior angles in half. So we've got 45 degrees, 45 degrees. And again, that takes the characteristic of the rhombus. Ntlako, do you have any other characteristics for us?
No, ma'am. I wanted to say the last one that she gave us.
Well done. Well done. Okay, it's one that we often forget. So very nice for remembering that. Thank you. Botale, any others?
Ma'am, I also wanted to say that diagonals bisect the angles at each vertex.
Nice. Oh, very much nicer than what I was writing down. Good. Okay, so guys, that last one is one that we often forget, but it is obviously important that we remember that one. So just remember that your diagonals do bisect the opposite angles. And let's also remember to mute ourselves. Let's now take our screenshots of the characteristics of the square rather. And guys, like I said, the square is the most like specialized type of quad that we work with. It takes characteristics of your parallelogram, your rectangle, your rhombus, and it puts it all together to get the square. Now, guys, again, like I really hope that we've been taking screenshots. I've literally just given my grade 11s all of this information again today. So this, like I say, this is going to carry on all the way up until matric. You need to know the stuff from grade 8 to matric. So it seems like quite a lot of talking, a lot of just like information, but it is so important. You use these characteristics and you need to know it. Yeah, absolutely. If you're taking notes, that's absolutely fine. It's more just I want to make sure that you guys have this information. Alrighty, guys. So all of these quads come together to form sort of this relationship that we have here. And so we have our basic quadrilateral there at the top. That quadrilateral can now be split or start to be specialized into our kite, our trapezium, and our parallelogram. And as you can see from this like family tree situation here, from our parallelogram, we now start to specialize either into a rectangle or a rhombus. And then we take characteristics of the rectangle, characteristics of the rhombus, and we get our square. And that's what I was saying earlier. Right, I see some people wanting me to go back to trapezium. I'll go back there in a second. But guys, so this is our sort of quad family tree, and we need to know how they relate to each other, how we take characteristics from one shape to another, and how we can, or knowing those characteristics. Because if I say to you, the shape is a square, you need to know all of the characteristics in order to use it. So when we start doing measurement, if I say, work out the area of a square, you need to think, okay, cool. I know that all of my sides are equal. That's important for me when I work out the area. So when we get to sections like measurement, having this information is super important. Right, I'm just going to go back up
Screenshots
to
from people. I hope that they're taking screenshots because these are very nice notes.
Right, so I've just gone back up to trapezium for those who needed to take a screenshot there. Guys, let me know now if I need to go back to any of these quads for you to take screenshots while I'm here. So we've got trapeziums, kites, parallelograms, rectangles, rhombi, and squares. All right, I assume we've all got our screenshots. Does anyone have any questions for me about the characteristics of our quadrilaterals? Oops. Tini? Tiny, I know we've had this conversation before.
Hi, ma'am.
Hi.
Hi. My question is, if they ask us in a test, where do we exactly get our marks?
So it depends what the question is. If I'm just asking you to give the characteristics, then you'll get a mark per characteristic. So say, for example, something like a kite, there's 5 characteristics that we have there, so you'll get 5 marks. We probably won't expect you to give all of them. I would maybe give you something or ask you something like, name one characteristic or give me 3 characteristics of a rectangle or something like that, and then it's a mark per characteristic. If we now start talking about measurement and stuff, which we'll get to, then you're going to start getting marks for working out the area correctly or working out a side length correctly or whatever the case is. But that comes into our measurement section, which we do a bit later.